Good evening, everyone. I would like to warmly welcome all of you for the public lecture on building scaling technology venture by Shannon Cannon. Actually, he's the chief architect of PICME or PICME Digital Mobility Solutions Lanka Private Limited, and he's a proud product of University of Moratuwa. And also he holds a Master of Computing, Information System and Project Management from National University of Singapore. Over to you, Shannon.
Thank you. Good evening, everyone. First of all, sorry for you to keeping for a half an hour wait. So it's I trapped in the traffic. So we are actually in PICME kind of vision to give a solution for these traffic problems and all the transportation problems and the mobility problems. So I'll go through what I have learned and actually what we have learned from building a system from a startup to a venture level. So building a scalable technology venture. So the main problem in the scalable system is, if you know the system technology, you need to manage the team and as well as the technology. So that is where the problem is coming. So scalability of the team and as well as the scalability of the technology is actually relying and building and helping us to build a scalable technology venture. While you are scaling the technology, as well as you need to scale the engineering team to bring the scalability of the technology venture. Let me just introduce myself. I'm Shannon Cannon and I'm the chief architect at PICME. I did my master's in National University of Singapore and did my engineering in University of Moratuwa. So this talks mainly about the journey towards a scaling technology venture from a startup. So I will explain what is a startup technology and as well as is going through what is a scalable technology venture. Startup technology. So how many of you are aware about startup, or how many of you are working on a startup? That's great, quite good numbers. Okay. So when we are building a startup technology, the main goal is to create the customer traction and understand the market and penetrate to the market very fast. We don't care about how it's going to be scaled, how it's going to be grow into that platform, or how it's going to be working out for 1 year. Only we need to target growth. So the main focus is to focus on the quick development, and we don't worry about the quick and dirty solution or anything. It needs to be very quick. That needs to be penetrated to the market very fast. And we are not much worried about the scaling. What's the problem going to come 2 years later? No. What's the problem coming to the 1 year later? No worries. We only need to worry about whether we are going to give the solution immediately as fast as possible. So when reaching a startup, after it's reached a certain maturity level, what I mean by maturity means, let's say customer has accepted the product and they have understand what the product is about to give. So once they reach the level, the technology is need to take over. It means the people's demands are going to impact the business very fast. I can give a practical example. When we launch it in PICME, it's very smooth operation, but when after a certain time, it's actually hit back us. We can't able to cater the demands what we are actually promised to give during the customer. So we need to understand what is growth versus scaling. So anyone know what is growth? What is scaling? Let me introduce what is growth. So in a growth, normally you will add the resource, whatever the resource, technology or servers or resource, human resource or whatever, in a line with or is a proportion to the revenue what you are getting. But the scaling is totally different. You will get the revenue in an exponential rate, but you will align the resources or attach the resources in an incremental rate. So growth is different, is actually going in a streamline and the same rate of the revenue, but this one scaling is growing exponential rate, 1x, 10x, 20x, 100x, 1000x, even 10,000x. But the resources you will align 1x, 2x, 3x, 4x in an incremental way. So what is the big deal of organizing the scalable venture? Why it is hard? Because you need to align the technology, align the systems, and you need to align that team. It means scalable team. Peoples are different from softwares are different. And you need to have a process, both need to be in align with the technology and people. Then you will need to align everything to bring to scalable technology. Let me introduce about how to build a scalable system. So as I told you, when the startup get into the product market fit, it will hit by the order of magnitude of the customer demand will always going to be hit back. It means they will expect more as what you are giving. When you are introducing a product, customers don't know what they need. So when you started to give, okay, you can easily hail, you can easily do a payment, you can easily shopping, then only they will realize, hey, my experience is improving. Then after that, they will actually demand for it. So you need to keep on giving and keep on improving. If you are failing to keep on in the cutting edge of the technology or cutting edge of the curve, what will happen is another one will overtake you, because you already implemented and already show the market this solution is working. So you need to be ahead of the curve. So to cater that limit, the systems need to be flexible and as well as available for the customers, and as well as it's needed to cater the growth of the demand. So why it is flexibility need to be important? When that demand comes, when a customers request some features, you need to implement the feature very fast, and also we need to be implemented in a non-breakable way. That's flexibility need to be in the system. And then once comes to availability, when you implement a system and the system is in place, you can't take it back. You can't say now you can't get the function now. So system need to be available when the customer actually need for it. So its availability need to be up and running. Then the growth. Today one customer will use, word of mouth will spread, they will start to talk about it, the world will pronunciate the name, then what will happen is the demand will go up. So system need to have a flexibility, availability, and as well as it need to have the capability to handle the growth of the demand. Let me put it in a practical example. So when the Pygmy launch, we got actually 1x. It means 10x hailing request. So hailing orders we got per day. But it's actually we handle nearly thousands requests per second, thousands per request per day at the time when we launch with a very small team, 5 people. Then it goes to the 1 year later, it goes to nearly 500x. It's only 5,000 hailing orders per day and 10,000 requests per day. When it goes to, it's actually handled by the 10 development team, 10 team members. Another year later, it goes beyond the control, it's 5,000x. It means 5,000 hailing requests, 50,000 hailing requests, 1 million, almost 1 million requests per day it's handled, and 20 engineering team. So you understand the growth and demand, how it was created in the market. So we need to have the technology in place, and as well as the resources and as well as the process need to be placed to handle this growth. Now, within a 4 years time, less than 4 years of time, it's handled 30,000x, it means 30,000 growth. It's not a growth actually scale. And that every day we are handling more than 300,000 hailing requests, hailing orders, and as well as 1 million events per second is actually producing. Earlier we had 1 million requests per day. Now it's actually 1 million events per second. In a blip of a second, it's creating 1 million events across all the system and handled by the 100 engineers. So just a simple is one of our investor take this picture about our internal monitoring graphs, and this one I'm just putting for you a curiosity to understand how big the system is running in the background, how much resources, how much monitoring, and how much individual components are running behind the scene. A distributed event-driven system built from scratch, proudly built from scratch in Sri Lanka, and from that engineering talents in here. So can we build a scalable system in a day one of a startup? It is not practical, as I explained, because when we launch a startup, the focus needs to be growth to capture the market. So when we are starting with a monolithic application with a simple, fast, and as well as small system, the main focus is to give what customers need to prove it to the market whether it's working or not. When we build the system, when the customers get tractions, it started to get, we will understand there are certain components started to fall apart. So what we need to identify which are the components which actually demanding most, and then we need to make sure that system, that components need to be scale in any number of times. It means, let's say, for example, if you take a sales ordering system, so customers will start to put the request. So that is the front facing application is actually started to get the most demand of the customers. So we need to plan to scale, how to scale this application, small component, in an exponential way. So what the plan is to make them as a microservice, as a synchronous microservice. That is the first step we will take to make it a scalable system. So this synchronous microservice will give a 10x growth for us. It normally gives 10x to 100x growth for us if we have properly designed. So it will give an interconnected and horizontal scaling capability to the system. Now let's identify 4 or 5 components and make it synchronous microservice. We have done, but it also have a limitation. It's a synchronization. When that particular service have any problems or any malfunction, it started to impact from top to bottom. It means whatever, depending on the synchronization, started to get failed. So the whole system have a risk of failure. So even though you can scale this, putting a load balancer in front of this microservice and scale it horizontally with any numbers, but it's also having a point of failure. So what is the next plan? We need to make this synchronous service asynchronous. Making synchronous service asynchronous is an upside down, because let's say if an order comes, we will process by individual request, by going through validation, then after that accepting, processing and completing the order. So if you make a small component as asynchronous, it is straightforward. But if you make that component as asynchronous, you need to think bottom up. You need to introduce certain event bus. The terms of event bus will introduce, then horizontal scaling will be introduced. When the event bus comes, how you are going to handle these events, and where you are going to store the event, how you are going to make sure the events consistency are available, everything started to play a part. But it will give a 100x and more than 100x growth for you. Once you build that single asynchronous service, you need to think about how you are going to distribute this complete asynchronous service. When you bring the distributed system, it will give more than 1000x, maybe 10,000x. That's what you need to build. It's kind of a dream to everyone to build a distributed event-driven system. So it will give us horizontal scalability, it will give the event-driven architecture, it will give the event-driven, and also it will give another headache to how to manage the cap theorem. How many of you know the cap theorem? Have you heard about cap theorem? Okay. So cap theorem is actually talking about what is consistency and availability and partition tolerance. In a distributed event-driven system, you can't achieve consistency, availability and partition tolerance when the network partitions are enabled. Let's say if you enable with a distributed system with multiple components, you can't achieve 3 of them at once. You can achieve only 2 of them. So if you are considering of the consistency and availability, partition tolerance can't be achieved. In other way, if you are considering the partition tolerance means you are distributing the application. If it is one fail, how is going to be, other applications are going to be handled. If your partitions fail, we need to come to a situation, are we going to say the customer, now the service is not available or service is malfunction, then that availability is going to be in a question. That consistency will be there. If you think about the consistency, you can't bring the availability. If the data consistent, if you are worrying about, you can't bring the availability at points. So this is the game that needs to be played. So the application need to be handled all this situation to handle this cap theorem. So in a distributed event-driven system, that's need to bring how we can bring that cap theorem into practically we can solve it. Actually, we need to bring a lot of other functionalities like failsafe. If the failure happens, how we are going to recover from the failure. It means auto recovery from the failures, and how the breaks are going to be worked. So these things we need to be considered when we are building a distributed event-driven architecture, event-driven system. So failsafe means, let's for example, you are putting a simple hailing. You don't know how many things are happening in the background. I'll give a simple example. When you are putting a hailing here, there are a lot of algorithms to find out which is the best driver for you. So but if that particular service is down, or if it is not down, we have a failsafe mechanism to find a best driver with a minimum capacity. It means you will get, the system will be available, service will be available, but data consistency won't be there. You will lose certain things. But this kind of tolerance you need to have. If you are building a fintech technology, you need to think about how you are going to consistency, or you are going to have the availability, because data consistency is very important. If a customer goes into an ATM and he is withdrawing money, you can't have an inconsistent problem there. Whatever in the money in your account, you need to show. If you go in a debit balance, it's gone. So whenever that depends on the platform and the product, you need to bring this CAP theorem into place with the proper alignments of failure safe and as well as auto recovery. So we are using, to bring to this event sourcing and distributed things. So Kafka is a fundamentally event bus we are using to have event-driven architecture. So fundamentally Kafka is as a log aggregator, but we are using it as event sourcing because it's have all the functionality what we need for the event sourcing. When you're building the distributed and scalable system, technology is a choice. As I explained, when we're starting a business, when we're starting a startup, we will make a decision very fast. It means we will make a quick solution and dirty solution. But I'm telling you, believe me or not, that's a quick and dirty solution is an infection. It will kill you from inside. Not today or tomorrow, it definitely will happen. Whatever you put a patches or whatever quick solution, it'll hit back here. So we need to once we reach a stage, okay, thereafter you can't make this quick and dirty solution. You need to be processed, you need to make a decision with the proper technology choice strategy. So how you're making a technology strategies during a scaling stage. So normally the scaling races, during the technology scaling race, we will take a technology decision without any compromise, and as well as we will choose for the best. Wherever resource, even if it is not in Sri Lanka, let's say if you don't have a resource in house, we are ready to get it from anywhere. So we need to have that kind of mentality to adapt the technology, adapt the knowledge, adapt the advice or consultancy from anywhere, any part of the world, because we know certain things, but there are people already done certain things. If we want to know to build those things, immediately we need to connect with them and get the knowledge. There are platforms available, Upworks and freelancers everywhere. You can get the resources anywhere. Even if you want, you can get them in Sri Lanka. They are ready to come, they are ready to help you. Only way we need to connect with them. You need to be open and you need to be adept and you need to accept what we are telling. Then your decision based on your experience, whether they are telling is truth or not, you will take the decision. Organization technology venture. So far we have seen how we can scale the systems, and now we need to see how we are going to handle the peoples. So systems are different, peoples are different. Systems are hardware, peoples are wetware. So both are different. So if you are building a scaling technology venture, you have to consider both. You can't only focus on the technology. People's actually started to, when you started to building the scalable team, people will start to work in a different manner. People is not like system. They will have egos, they have feelings, they have morals, they have culture. Everything will start to impact your team. So, but the scaling tech system, even though if you are not considering, they started to impact the people. They will feel the system is changing, they are adapting. Okay, now the technology is evolving, I need to learn fast. Everything will be started to involve in the people. So how to adapt it? Okay, you can find people, okay, to scale the technology. You can bring more people, you can add more people, you can hire them, but it won't solve the solution. What you need to do is you need to refactor the team culture. How the cultures work in the organization within the team is need to be completely revamped and need to be ready to scale at any level of time. What is refactoring the culture? So everyone know what is organizational culture. Every organization have their own culture, but if you are planning for a scalable system, scalable technology venture, we need to build a technological culture, and the culture that need to be help to improve the scalability of the system and as well as the organization. So what we experience is, if we keep the structure as flat as possible, without any hierarchical, without any titles. We have the titles, but we don't have a hierarchical plan. So if we have that one, things are working very smoothly. Anyone can go and talk with any hierarchical positions anywhere. So they will get cleared. They don't have any doubts. They will have a safety internal safety, and they will trust the people, and also they will start to feel accountable. What I mean by accountable, so if you, let's say if someone is coming and saying, hey, this is a way it needs to be implemented, what you are thinking wrong, even the person is actually a junior person, no matter how experienced person he is telling about, if he is telling right, if we believe him, we'll give a chance for him, and we'll give guidance, and we'll give the opportunity him to prove it. So once you prove it, his confidentiality, confidence will go up, and trust on the team will go up, and he will start to feel the safety. That's how we build the culture inside every team to bring this organization culture in place. Second one, everyone in the organization need to welcome the knowledge from outside, because we know we are going to grow. We are not stopping. So the talent will come from anywhere, any part of the world, within any part of Sri Lanka. So, but when they are coming newly, they need to adapt with the existing team, how they are going to work with the existing team. And also, existing team need to help them to adapt to the environment. So, the existing team need to welcome the new person at any cost by motivating and encouraging them to take part in the team. We need to build a clear communication between teams. There should be any assumptions or anything within the teams. If you are not understand, you need to come and ask, okay, as much as explain the things, because we saw this problem, because whenever its assumption comes, things are going and develop in a wrong way. When I'm telling a person, okay, this need to be something like that, he can't assume me, okay, but I'm telling, and won't come and ask, okay, whether I'm telling 100% correct, because everyone will believe what I'm telling is 100% correct. But I'm thinking in a different angle, he's thinking in a different angle, end of the day, product comes in differently. So we come up with a plan with the proper documenting and everything, documented, clear communication. It will help us to improve the assumptions. There's no assumption. If it is the assumption, make sure it's cleared before it goes to the development or anything. The most important part, guidance and mentoring. The technology is new, the team is very young. You need to mentor them and guide them to bring to the level what you are expecting. They need to run very fast. They need to go home and go do the homework and come back with a solution, and they need to find the alternative, how we can better to find it, how we can actually build that internal event source, and how we can build that streaming platform, how we can actually decode that messages, everything. They need to come up with a different approach. So they need a guidance and they need a mentoring with the past experience. And very important, we need to build a very micro teams. What I mean by macro team, the team size need to be less than 5 to 6. It means if we have more than 5 to team, it is never work out. So 5 to team members, it's actually they have good internal communication and they are working closely and they build the platform very effectively. And don't make the team, and also don't make a mistake of bringing a new recruit to a new team. If you are getting a new recruit, put it with him with the existing good team. They will train them with the culture, they will train them how we are operating, they will train the knowledge. Then after that, form the team with the new recruits. Then they know it's kind of a DNA replication of the existing team. They will replicate the DNA of the existing team and create a new team. So they will function independently and as well as in a productive way. Right, people are good at small team. As I explained earlier, it's actually the 5 to team member team. It will be very good for an operational kind of any team. So currently we are competing with international with a small amount of team, with a small amount of power in the human power in the organization compared to that international competitions. We have talked about scaling the system and scaling the team, admin peoples, how we can balance the scaling. Then now we need to look at how we are going to balance both of them together through a process. Both systems and people can fall apart if anytime anything goes wrong. System can go wrong, people can go wrong. People can fall apart from the things and system also can fall apart. If anything goes wrong in the external system, can impact the people and as well as the system. So how to make sure everyone is in a line? We are following the delivery discipline order. We need to make sure that the engine is rolling very fast and as well as effectively to make sure that it's producing more outputs. So we need to have some delivery process need to be in place. It will be starting from a scratch. If you're joining an existing venture, it's an established venture, those processes are already in place. But if you're evolving from a startup, if you are evolving from yourself, you will see these things transition happen from day to day. New process will need to be implemented, new project managers need to be recruited, they will come as a senior project manager, they will guide the project and programs, so they will go through the agile processing and they will go through daily scrums and they will scrum ceremonies need to be happened. This process will help us to maintain, and the scrum practices help us to improve the delivery and as well as the good communication through the product owners and as well as the clients. So if you take the quality controls, certain quality controls need to be implemented, code check quality and as well as functional testing need to be done, test driven development need to be done, some simulation need to be done, certain performance tests need to be done. These checks need to be done to make sure systems are working smoothly once it goes through the production life cycle. So earlier when we start the development within the startup, we'll develop the code in the laptop, immediately we'll push back to the production. But now it's going through a multiple level of check to reach that level. The transition is not simple. Every day, every time you need to train the team, why you need to communicate to them why you are implementing this. If you enforce something on the people, they will start to reject it. So, but you need to introduce them as a culture. Okay, you need to, if you are doing this one, it will improve your quality. If you improve bugs, it will improve. There's no bugs. I mean, bugs won't come or anything. If you tell the reasons, they will start to react to the external things. Very important, incident management. So there are a lot of failures will happen in the productions. Currently we are running nearly 5,000 cores of CPUs in the cloud, in the multi-cloud environment, Google Cloud, AWS, Azure, and as well as local internal Sri Lanka cloud solution as well. So within this one, there are a lot of failures will happen. If the failure happens, we shouldn't get panicked, we shouldn't get overreact. What we need to do is we need to understand, okay, why the failure happens, we need to prevent the failure happens from the next time. So to achieve that one, we need to find out what is the root cause, why it's happened, how it has happened. Then we need to come to a solution for that one, then make sure that is not happening in the next level. So whenever the problem happens, it's good for us, we will learn and also we need to adapt, then we will mature enough and to go to saying, hey, it won't happen next time, we will make sure everything is happening, every precautions have taken, corrective measures have taken to correct it. So incidents management process will help us to improve our internal systems availability and as well as the system availability go to a greater level. Right. Scaling tech is not a rocket science or is a brain surgery, but it is the brain science dealing with the people and building a rocket surgery. What I mean rocket surgery means is actually building a startup is a rocket. Once it launch, you can't come back to the launch pad. You need to go to the orbit and you need to go beyond it. So if you want to do that one, you need to have the good people management and as well as the good rocket surgery. While you are running the rocket, you need to attach and detach certain services, certain engines need to be built, certain engines need to be improved, these things need to be happened over time. So this is what all about scaling a technology venture. It means starting from technology, then go to the people, how to manage the people, how to eliminate their fear, build their confidence on the system, or build the confidence on the venture, build the confidence on the team, build the confidence on the leadership, then bring them to the pool, then how to go to the process to implement this thing. I am done. Anything, any questions or anything? Ask for questions. Great. Can you, I can't hear you clearly. Sorry. Yeah. Okay, fine.
But anyway, I had actually two questions I wanted to ask you. One is from the HR, tools, people management, what you create. Quickly has something like a month is not the they call that like a homegrown London company. But I want to ask, like, what's going to be, how do you plan your tools or technology teams so that we can do the next technology disruption, as we've done in the past, like how you mentioned on that. But second question is, move on to the topic of responsible. I'm a mechanical engineer myself. I work for the US on transport electrification. That's an interesting space for you. Look from the neighborhood perspective to support electric vehicles and traffic space. But of course, there of course you realize transportation itself was changing because people are thinking about mobility as a service. People are not going to be that vehicle ownership is not going to be that here. So I'm wondering, a big how is it changing future transformation? If people are requesting more and more electric bikes, electric vehicle bikes, we're thinking of that if there's a good buy less cars in Lambo. Are you thinking of that right now?
Of course. Let me answer the first question. So the first question is regarding the teams and how we are going to disrupt that other technological space. So currently we are working on the mobility, but this option is open. We are actually working on other things, but I can't comment on what other things we are working on. So we are ready to disrupt, and the technology and as well as the team is more energetic than me actually. So they are very young and they know the technology, how to use it. They will be working on the disruption part. So let me come back to the second question. So the second question is autonomous car and this stuff. It is far, but actually we can do it. So in-house actually last month also I read some articles in that one. University of Moratuwa, there's a mechanical professor who built it. Electronics 3 wheels. So it's just a matter of we already interconnected auto mobilities. So we know how the mobility worlds are working. So just a matter of playing with that autonomous engines and as well as the technology and data we have. Building and not building the technology, piece of the data analytics, bringing the technology together.
You mentioned about the key for forming the organization. I mean, first of all, I think that I'm not from a technical background, and in fact, I mean, when you really form that team, my question is that how do you really align the team vision with the system vision? I think you should conclude that the experience having that kind of equipment that are working. So I just like to know that whether you have any solutions for that.
Okay, that's an interesting question. So assigning that organization vision into the team. So normally we will have a flat structure.
Yeah.
So the team have a direct access to the executives and as well as the C-levels people. So they can share that ideas and share that vision. If they, even a junior guy can immediately go to the CEO or the CTO or the chief financial officer, immediately share, okay, hey, I have this idea, whether it will work out or not. They will give a constructive feedback. That's a constructive feedback will help them build the confidence, and also they will think be a part of the team. And also we have actually the CEO and CTO, CFO will come and sit with the people. They will never come and command. They will come and sit with and saying, hey, it is not breaking. So, and also we have an internal good communication mechanism. We are using all the communication channel, WhatsApp, Viber, and phones and everything. Immediately they will call if anything goes wrong. So let the team feel that they are accountable and they are the owner of the product. Once they feel it, even midnight if I call them, they will ready to work. There are situations happen. We work midnight because systems are not functioning well. So people they are not reluctant. They are ready to accept. And they are making a proud of it because they feel this is my product. I am giving that one. So we have a brainstorming session. They will share their feelings and share their ideas. So once they share it, there will be a constructive feedback from individuals. If it is a good, that will be taken to the production release. So fundamentally, you need to keep that gap close. Then everybody will understand. Okay, he is not from alien. He is one of them. Yeah.
So working with the startup also. So I have a question with regarding the company, like we have a monolith working and some cloud. So on both sides. So when you were scaling, what were the signs that would report that the model is failing and we need to go into article?
Very simple. System won't function well. Every evening, every Friday, we started to fail service downgrades. We are struggling to bring the system because customers are demanding for a vehicle. If they're raining outside, we can't able to give the vehicle, systems will fall apart. So we know it's actually failing apart. So we understand where the system failed. We understand, okay, that is the best component need to be scaled now. So it means what's the component base means which is one from phasing or which is one getting more traffic, which one need to be get more resources. Then we started to
Based on the conversion of microservice, based on the traffic and that kind of.
yes. So I'll give a practical example. Okay, every 10 seconds, drivers are giving their locations in a heartbeat. So is everyone know that's how everyone we are actually identifying where the driver's location. So when we scale, when we had a problem, when we reach a level, we started running 8 CPU and 16 GB nodes with nearly 4 clusters. We need to be able to handle this load. But we keep on adding this node is not solving the problem. What we did is we did a transition, build a microservice using Golang, work in a worker model, asynchronous worker model. It simply solved the problem. 2 CPU, 8 GB RAM simply solved everything. Earlier we have 8 CPU, 16 GB RAM with 4 clusters. Now 2 CPU with 8 GB RAM, single node will handle. For the higher availability we are making as a 2 nodes. So these kind of things will help. I mean, we never make a choice of technology that we know these things, but we'll look at okay, whether if it is good, Java or Node.js or Golang, we'll choose based on that one. So we have a stack of Golang, Java, and as well as Node.js, and even we have certain applications running in PHP and Golang as well.
And on the cloud front, you mentioned that you have worked on many cloud solutions.
Yes.
So your solution is a cloud independent solution or is it a cloud specific feature?
No, it's our we are not like to marry with the cloud solution. So we are actually little far away from cloud solution what they are providing. We are using the cloud as a cloud only. We are not we are taking any functional benefit from the clouds. So because if we marry the cloud functional, then we can't take an independent decision to go move anything here. So anything had happened, let's say if that outside network, outside traffic, outside interconnectivity cut off from Sri Lanka because we are an island, anything had happened, we can't say we can't operate. So our system need to be operated even in the local data center. So we actually span across all 4 data centers, or cloud solution providers to make sure applications are working smoothly.
I have one question. So you mentioned that you are married with any other provider or any other provider who is giving any service to your whatever application. But are you getting some connectivity from Google Maps? So
Yes.
you are using your technology
So, okay.
also to move away from.
So completely with the Google Map, but what I mean by married with the Google function, cloud functionality means their cloud is providing certain functionalities, Lambda functions and app engines in the Google Cloud and certain big data analyzing. So we are not using that much those functions because if we develop those applications into that thing, we will be getting married to with them. We can't work without them. But Google Map is an individual product. Actually, Google Map is excellent, giving us all the functionalities we need. But we are using for analyticals and as well as certain distance calculation, this stuff, we are using our custom developed product. Only for mapped things, we are using the Google Map. Any questions? Yeah, sure.
I was reading that I was the information. Can you give some detail about what's the response time?
Sorry?
Response time, I mean, so when you take call for the whatever TV
Okay.
so do you have any idea that how long that
So our benchmark is actually less than 50 millisecond from connecting from Sri Lanka to come back. So our microservices are running less than 25 milliseconds. So, but certain applications, certain microservices, it will take nearly 500 milliseconds, 200. Let's say if you take payments, you're doing a credit card payment, it will go through different channels and coming back to you. Maybe it will take 3 seconds even. So mostly our internal services are performing less than 25 milliseconds. That's our benchmark. Okay, thank you guys. Thank you for your evening.
Okay, thank you very much, Shantan, for that interesting talk. Actually, so it is interesting to see like you started with a 5-engineer team, and you develop into now you have more than 100 engineers working at your company. It is nice to see Sri Lankan-based startup. How long you have gone up to today, and thank you very much for your interesting talk and how you have shared a lot of information to people who are interested in developing their own products or like their startups. Thank you very much, Shantan. And finally, thank you very much for all of you coming here and like for this public lecture and participate for that. Thank you very much.